Okay, on the second page here, number 9, we're going to give you a pretty simple completing the square question to solve. And completing a square is a process where we try to make the trinomial into a binomial times itself, or a perfect square. So in order to do that, we're going to need, this 6 is not going to be the correct term here, so we need to move it to the other side so that we're able to go ahead and find the third term over here that will make this factor into a very nice perfect square trinomial. So I'm going to subtract the 6 over here. Okay? So in order to come up with this term here, what you want to do is you go through a process of that's called completing the square, and in that process this third term will equal, I'll write it over here, 1/2 of the b term here, and because the next step we're going to square it, it really doesn't matter whether you take this negative sign with it or not. So we're going to take half of 2, which in this case is going to get you 1, and then once you have the 1, you're going to square that 1, which in this case becomes 1, and that'll be the term that you're going to place in as the constant in this trinomial as your third term. So this is going to be a positive 1. And that's going to be the process you go through all the time. If you're going to complete the square, you take half of this term, you get a value, and then you square that number, and that number goes right there. Okay? But in this particular problem, we just added 1 to the left-hand side of the equation, and in math you can't do that unless you do the same to the other side. So we're going to add 1 to the other side of the equation as well. Okay? Now, this perfect square trinomial is going to factor very, very nicely. It factors into a binomial times itself. Okay? Now, technically, that is the same as writing it twice, but we're only going to write it once because what we're going to need to do in the next step. But if it helps you to write it twice in this step, you can, and then you can make one additional step and then write it as a binomial squared. So again, just like if we were doing it in 2 separate terms, the first term here has to get you the first term here. But in this case, it's going to be multiplied by itself. So what times itself gets you x squared? That would be x. Now remember, the outers and the inners have to get you the middle term. And in this case, because the middle term is negative, our sign here is going to have to be negative. And then the last term here times the last times itself has to get you the last term there. So in this case, what times itself gets you a 1? That's going to be a 1. Okay? And then we just combine like terms on this side, and that gets you a -5. Okay? So we've got the square completed and factored, and now we've just got to go ahead and solve for x. So we have 2 things that need to come to the other side. We have a squared and we have a -1. We'll move those both over one at a time. Since the square is on the outside of this parentheses, we need to get rid of that first. So the opposite of squaring, of course, is taking a square root. So if we take the square root of the left side, you're just left with the x minus 1. And then if you take the square root of the other side, remember, when you take a square root, there's always 2 cases, a positive and a negative. And that's going to be positive, negative, the square root of -5. All right, so here we've got one more thing to bring over, and that's going to be the -1. And also you will notice that we have a negative under the radical, and so we should probably bring that out. So we'll do that both in this last step. The 1 will come over by addition, so when the 1 comes over it becomes positive. And then we've got plus or minus, and again, since this was a negative square root, the negative comes out as an I, because remember, I'll write it up here, I is equal to the square root of -1. Okay, so this is I square root of 5. So it looks like in this case we had a complex or imaginary number for our solution. Okay, so that's the process of completing the square. We have one more problem here, one more method, which is the quadratic formula. So let's refresh our memory. I believe Mr. Thomas made this song famous. X equals the opposite of b plus or minus square root. of b squared minus 4ac all over 2a. Okay, so we appreciate Mr. Thomas's little song there. And I believe you're supposed to do a little clicking action in there. Forgot that, but I'm sure you'll forgive me. So here, we want to use this quadratic formula, and remember, standard form is ax squared plus bx plus c equals 0, and it needs to be in that form prior to using this formula. And you might notice here that the 1's on the wrong side of the equal sign. So we're going to need to bring that over first. So we get 5x squared plus 5x, and we're going to need to subtract the 1 since it's positive on the right-hand side, and that's equal to 0. And now all we need to do is plug this in, remembering that this is going to be your A, this is going to be your B, and this is going to be your C, and the signs out in front have to go with those numbers. So in this particular case, you've got x equals the opposite of b, which in this case is 5, plus or minus the square root of 5 squared minus 4 times a in this case is 5, times c, which is negative 1. And that's all over 2 times a, and a in this case is 5. Okay. So now all we need to do is reduce this. So in this case, we've got the negative 5 out in front, plus or minus square root. I usually break this up into two parts here, 5 squared, which gets you 25. And then here you've got a negative 4 times a positive 5 times a negative 1. So a negative and a negative times a positive is going to get you a positive, and 4 times 5 is 20, times 1 is 20. So this then will be all over 2 times 5, which gets you 10. So then x is equal to, oh no, you haven't been able to see any of that, have you? So let me go back through this. You've got opposite of b plus or minus square root of b squared minus 4 times a times c all over 2a. And then brought down the negative 5. I squared the 5, multiplied these terms together to get the negative 20, and then that's all over 10. Okay, so then we can simplify this a little bit more. This is negative 5 plus or minus the square root of 45 all over 10. But the square root of 45 can reduce. There's a perfect square of 9 in there, 9 times 5. So x is going to equal negative 5 plus or minus square root of 9 gets you 3, square root of 5 all over 10. Okay? And it doesn't appear that there's a common factor between 5, 3, and 10, because remember this 5 is under the square root, so that is not a common factor, because that would need to be a factor of square root of 5, and we don't have any other square root of 5s here. So this would be your final answer for the quadratic.